concept, my dear students. The type of reactions developed at the support points. See here, it is a beam. This is external load. Here is reactions. Due to this load, reactions are developed at this is A point, this is B point, this is RB. Due to this load, reactions developed at the support point depending upon the types of supports. Now, the next concept here, types of supports. Types of supports. Types of supports. There are three types of supports, my dear students. The first one is hinge. Hinge or pinned support. Hinge or pinned support. Next one is roller or frictionless support. Frictionless support. Roller or frictionless support. Third one is fixed. Fixed or built-in support, my dear student. Built-in support. Built-in support. These are the types of supports, my dear students. So first of all, we will discuss about one by one. Okay? So see here, my dear students. So first of all, we will discuss about the hinge or pinned support. Hinge or pinned support, my dear students. So hinge or pinned support. Hinge or pinned support. All of you see, my dear students. Now this is x-axis direction. This is y-axis direction. This is z-axis direction, my dear students. Now there is a hinge support is like this. Hinge support is like this, my dear students. Here it is a beam. This is a hinge support. Okay. Now we are drawing the free body diagram, my dear students. What is a free body diagram? See, my dear students, here is a hinge support. Here is a hinge support. Nothing but my hand is there. My hand rotate about this z-axis. This is x-axis. This is y-axis. Perpendicular to myself, that is z-axis. Now my hand is rotated about this hinge point. Here is a hinge. Now my hand doesn't move in this direction, doesn't move in this direction. So similar fashion here also, motion is, we will draw the free body diagram. Motion is prevented in x direction. This is x direction. Motion is prevented x direction, my dear students. Next one, here is y-axis direction. Here also, motion is prevented in y-axis direction also. So, but rotation about z-axis, this is this direction. Rotation about z-axis, that is perpendicular to both. So, the rotation we cannot prevent it here. So, the rotation cannot prevent it here. Whenever motion is prevented, only at that time reactions are developed. Otherwise, there is no reactions. See here, my dear student, motion is prevented in x direction. Yes, there is a one reaction in x direction. Motion is prevented in y direction. There is a one reaction in y direction, my dear student. Now, I am drawing the free body diagram. Free body diagram. For this, here is motion is prevented in y direction. Motion is prevented in x direction. Okay. Now here, so this is a RA. This is a RAY because it is a y direction. It is RAX. This is x direction. Motion is prevented x direction. So this is RAX. Motion is prevented y direction. That is RAY. Now, how many number of independent reactions? 2 reactions. Total number of reactions is equals to total number of reactions. Total number of reactions is equals to 2. Total number of reactions is equals to 2, my dear students. Whenever this hinge support appears, at that time you must use this type of free body diagram. Number of independent reactions are 2. So this is about hinge or pinned support. Next one is roller or frictionless support, my dear student. Roller or frictionless support. Here is what is the examples for this are. What are the examples for this? There is a laptop in there. Laptop hinge is there. The laptop, see, monitor doesn't move in x direction, doesn't move in y direction, but it can rotate like this, about that axis direction. Okay? Yes or no? That is example here. Next one, coming to, here is roller. Next support, my dear students. Roller or frictionless support, my dear students. Frictionless support. Roller or frictionless support, my dear students. So first of all, similar fashion, we have to draw the x-axis here, y-axis here, z-axis here. See, now this is a beam. This is a beam, my dear student. This is a beam. There is a rollers are provided here. Rollers are provided here, my dear students. See, here, this can be written like this, but there is another fashion also. It can be rotated, it can be represented like this also. This meaning of both are same. Either use this one or this one. Both are same. Now, it is a roller or frictionless support, my dear student. See, there is a briefcase is there. We are carrying the luggage. There is a rollers are there at the bottom of the briefcase. With the help of the rollers, we are moving the briefcase. Similar fashion, here is motion is. Motion is prevented? First of all, motion, we cannot prevent motion in its direction, but it can move this direction because of this roller. But the motion cannot be prevented in its direction, but motion is prevented in y direction. Motion is prevented in y direction. Yes or no? So here is motion cannot be prevented in x direction, but y direction motion is prevented. Yes or no? But in z-axis direction, the rotation can also cannot prevented here. Rotation cannot prevented about z-axis direction like this. It can rotate like this. Here is like this. Here is hinge. So it can rotate about z-axis direction, but it can move x-axis direction, but only y-axis direction motion is prevented. Okay? In y-axis direction only motion is prevented. So the number of independent reactions is equals to 1. See, we are drawing the free body diagram, my dear students. Here is a free body diagram. Now this is a beam, but only one reaction, my dear students. Only one reaction is here, that is RAY, because this is a point. This is a point. Here also a point. This is RX, RY. Now this is a point. Motion is prevented in y direction. So that number of independent reactions is equals to number of independent reactions is equals to only 1. See, whenever roller support appears in our problems, we have to put only one reaction. All of you clear, my dear students? This is about the roller or frictionless support. So the next one is fixed or built-in support. Fixed or built-in support, my dear student. Now I will write here. I will write here. So the next one is here fixed or built-in support, my dear student. Built-in support. Fixed or built-in support. See, my dear students, here is, this is x-axis direction, this is y-axis direction, this is z-axis direction, my dear students. Yes or no? Now, here is a beam. Now, one end of the beam is fixed here. One end of the beam is fixed here. Yes, sir? Now, all of you see, my dear students. Now, we are pulling this direction. Is it move? No. So that motion is prevented in x direction. Motion is prevented in x direction. Now we can pull this direction. Is it move in y direction? No. Motion is prevented in y direction. So are you able to rotate like this? May I try to move? I am applying force here. I will try to rotate like this about z axis direction. Is it rotate? No. So that it cannot rotate about z axis direction also. So the rotation about z axis also prevented. About z axis also prevented. When motion is prevented in x axis direction, one reaction is developed. When motion is prevented in y axis direction, yes, one reaction is developed. Rotation also prevented about z axis direction, so that one reaction is developed here. So see, we are drawing the free body diagram for this. So now it is a, here is motion is prevented in x-axis direction. This is a point, my dear student. This is a point, my dear student. This is RAX. Motion is prevented in y-axis direction. This is RAY. But I can try to rotate about z-axis direction. I will try to rotate this direction, but opposite direction, resistance developed. So this is here. So this is RAZ. So that is nothing but moment. That is nothing but moment about z-axis. Yes. So motion is prevented in x-axis direction, one reaction. Motion is prevented in y-axis direction, one reaction. Rotation also prevented about z-axis direction, so that one reaction. Total number of reactions. Total number of independent reactions is equals to total number of independent reactions is equals to 3. Are you clear, my dear students? Whenever this type of support occurs, at that time you must use this type of reactions here. Are you clear? So what is our first one? So types of supports: hinge or pennant support. In hinge or pennant support, number of independent reactions is equals to 2. Roller or frictionless support, number of independent reactions is equals to 1. Fixed support, number of reactions is equals to 3. Thank you, my dear students.